Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a radical equation with complex numbers. If you're new to complex numbers, go ahead and check out my lecture videos. I also have another channel called Math, cyber with an S, where I solve number theory, algebra, calculus problems. All right, so let's go ahead and take a look at this problem here. We have z times the square root of z equals I, and we're going to be solving for z. Now, z is a complex number. What is a complex number? We can write a complex number as a plus bi, which is also the name of this channel, by the way. A and b are real numbers, and I is the square root of -1. When I say the square root, I'm talking about the principal square root, because a complex number has two square roots. Here, we also have to be careful about the notation, the convention. Square root of z is being used as the principal square root. Otherwise, there's going to be a confusion because it's multi-valued. Okay? Cool. So let's see how we can solve this problem by using these ideas. To solve this problem, obviously, one of the things that we can do is use the fact that z can be written as a plus bi. So let's go ahead and call that first method. And I'll probably present at least two methods. Let's see if you can come up with something else, or if you do come up with a third method, please let us know in the comment section. If you have any questions, feel free to ask in the comment section. Again, pretty much everything is in the comment section, okay? Great. So let's replace z with a plus bi. But then the question comes up, a plus bi times the square root of a plus bi equals I. How do you find a and b? Because to be able to solve for z, you need to find the values of a and b. So here's what I can do though. I can try to find this first, maybe in terms of a and b. Even though there's a formula, it's kind of complicated and I probably wouldn't memorize it, and I don't have it memorized. But I would start by calling this maybe something like x plus yi, because the square root of a complex number is also another complex number, right? So let's go ahead and try to solve. So our goal would be to find, let's see, let me think about this. I think we're going to try to find x and y in terms of a and b. Yes, so our goal is to solve for x and y, okay? Solve, let's take note because there are too many variables. So we're going to solve for x and y in terms of a and b, plug it in here, and hopefully we'll get something from there. Let's square both sides. We want to get rid of the radical. This gives us, and I want to write this first, x squared. Oh, by the way, I forgot to say probably, but one thing that you should never forget, I squared is -1. But wait, I already told you square root of -1 is considered I, right? So that would make sense. So when you square this, y squared, I squared is going to give you a -1. So I can write it like this, and then plus 2xyi equals a plus bi. Here we're going to run into some problems, which I'll probably make some assumptions, which may not be correct, by the way, but let me know, okay, if there's an error. So here we need to set the real part equal to real part. So x squared minus y squared is equal to a, and 2xy is equal to b. Okay, that's how two complex numbers can be equal, real parts to real parts, imaginary parts to imaginary parts. And then this gives us a system of equations. And remember, we were trying to solve for x and y, so this makes sense. Let's go ahead and solve for x and y. How do you solve for it? I can go ahead and square something here. Maybe that's one way to do it. Another method that I can think of, there's too many ways to do it. Like, okay, maybe I can replace y with b over 2x, substitute that here, come up with a quadratic equation. Or I can use this, remember the identity, and I just used it on my other channel, Cyber Math, today for another problem, which is about polynomials. So if you haven't checked that yet, go ahead and check it out because this is a really nice problem, and that's homemade. Hopefully you know what that means. So if you subtract these two things, like if you take a plus b squared and a minus b squared and subtract them, you always get 4ab. So this should give you 4x squared y squared, which is nice because we know xy, we know x squared minus y squared. So we can go ahead and substitute here. Let's go ahead and leave this as is, and then replace this with a, and This is a square too. So xy is b over 2. If you square that, you get b squared over 4, but then you have to multiply by 4, which cancels out. Houston, we have a solution. X squared plus y squared equals a squared plus b squared. This is awesome. You know why? Because from here you get x squared plus y squared is plus minus the square root of a squared plus b squared. So there are two solutions, and that's normal. We can go ahead and take one at a time. Since we also know let's just start with this and then use the fact that their difference of squares is a. We can go ahead and solve this as a system, right? Let's go ahead and add these up. This gives us x squared plus x squared, 2x squared, but then upon division by 2, we get the following. Square root of a squared plus b squared plus a divided by 2. Of course, that's x squared, so I kind of need to square root both sides, but then again, we have a problem because which square root are we going to take? The positive one or the negative one? Okay. Anyways, let's just go with the positives. And for the y, you're just going to subtract them. So y is probably going to look like this. You're going to have their difference. So it's going to look like something like this. And then guess what? You can plug these in to the original problem and hopefully go from there. Let's go ahead and find out. A plus bi times the square root of x plus a plus bi, which is this plus this I. So it's going to look like this. You probably noticed that the first method is not desirable. It's super duper complicated, right? I don't think you want to use that. But I just wanted to show you at least. And this kind of allows you to come up with a formula for the square root of a complex number. Of course, there are some signs that you have to pay attention to. I totally ignored them. But set this equal to I, which is 0 plus 1i. And then from here, you should be able to find a and b. But that's going to be super duper complicated. That's why we have what is called the second method. Okay, ready? Z root z equals I. Of course, that wasn't the first best way to do it. Probably the worst way to approach it, but it's still a method. Let me know what you find from here. But with my second method, I'm going to get rid of the radical right away. So why not square both sides, right? And when you do, you're going to get something awesome because you'll be getting I squared, I mean. Z squared multiplied by z is equal to I squared, which is negative 1. And then from here, you're going to get z cubed equals negative 1. How nice is that, right? You can put everything on the same side and then factor this. And let me tell you, you could also do this differently. There are so many ways to follow. Pick whatever you like. Now, in this case, I factored it because it's easy. And z equals negative 1 seems to be a solution, which we'll talk about later. And then this gives me a quadratic. Let's go ahead and solve it. It's going to give me negative b, 1, plus minus the square root of b squared, which is 1 minus 4ac. That's going to be root 3i divided by 2. Is that familiar? It should be. And I'll talk about it after this. But basically, those are the three solutions we find. Because it's cubic, there should be three complex solutions. So this one, and that one. But are they all good? That's the $1,000,000 question. You know why? Because they have to satisfy this equation, right? For example, take negative 1. What's the square root of negative 1? We talked about the principal square root, remember? So negative 1 on the complex argand plane looks like this. This is negative 1. Its distance from 0 is 1, which is the modulus, and it makes an angle of pi radians. Or you can call that negative pi, right? And when you find the square root of negative 1, isn't that I? I think so. So this is negative 1. This is I. Square root of negative 1 is I, right? That's the principal square root. So their product is negative I. This did not work. Why? Because we introduced extraneous solutions by squaring both sides. Remember, that happens with complex numbers too. And the idea behind the principal square root is you have to be very careful. So which one is going to satisfy this equation? Do you think there's going to be two solutions? I'm going to leave that for you to check, but I'll show you what Wolfram Alpha provides. Ta-da! Why doesn't the other one work? That's for you to check, because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.